So we're going to be looking at the Chapter 6 study guide for the geometry test. This is on parallelograms and other quadrilaterals and their properties. So we're going to start with simply a parallelogram shape here, and it says solve for the missing variables, of which we have two here. We have an x and a y variable that we need to solve for. So this requires us to use two properties. The first property we should know is that consecutive angles in a parallelogram add to 180, consecutive being side by side. So these two angles here will add to 180, and in addition, these two angles here would add to 180, these two angles here would add to 180, and these two angles here would add to 180, which again doesn't really help us out for these three, but the main one being that since these two add to 180, I can go ahead and make an equation. 4x plus 10 plus 4x plus 40 equals 180. And I can go ahead and solve that through. So we combine our x's, combine our non-x's. So we get 8x plus 50 equals 180. We subtract 50 from both sides. We get 8x equals 130. Divide by 8. And we get x equals 16.25. So once again, the first rule we used was that supplementary angles are always going to add to 180, so we just set up an equation of equaling 180. Now, in order to get the y, we know the second rule, which is that angles that are diagonal from each other are going to be congruent to each other. So this angle down here and this angle up here are going to be equal. So that means that if I figure out how big this angle is, I can set up an equation with this angle up here. So let me go back and plug this in for x to see how big this 4x plus 40 actually is. So how big is that 4x plus 40? So it'll be 4 times, my x is 16.25, so 16.25 plus 40. Let's see how big that actually is. So we plug into our calculator, that'd be 65 plus 40. Add that together, you get 105. So that angle is 105 degrees, 105 degrees. So that is equal to this angle up here, because again, they're both across from each other. They're both diagonal. So that means that I can set up an equation that 3y minus 6 equals 105. Again, diagonal angles are congruent. So you go through the usual process. You add 6, we get 3y equals 115. Divide by 3, 3, and you get y equals 37. So again, this one required two steps there, but the properties are nothing unusual. Again, side by side or top and bottom angles add to 180, and the diagonals that are across from each other are always going to equal each other. For the trapezoid, it wants us to solve again for both x and y. So we're going to set up two problems here, one for x, one for y. And it says that AM is the midsegment. So what a midsegment of a trapezoid does is it basically cuts the two legs in half. So this piece and this piece are going to be equal, and this piece and this piece are going to be equal. So let's go set my x first because that seems to be the easier one. So I can say 2x plus 9 is equal to 5x minus 12, because that's what the midsegment does, is it makes two equal halves out of the leg. Top half and bottom half would match up. So you solve this through here. Subtract 2x from both sides, you get 9 equals 3x minus 12. You add 12, you add 12, you get 21 equals 3x. Divide by 3, and you get 7 is equal to x. So again, mid-segment, you get two equal portions, so you set them equal to each other. It's basically bisecting this side here. So if you have a bisector, you're going to have two equal sections. Over here, you have one small piece and the entire large piece. So this is a case of double and equal. So you're going to take the small piece, 2y plus 6. You're going to double it, and you're going to set that equal double. There we go. You're going to set that equal to the large piece of 7y minus 12. So in that case, what we're going to do here is, again, we take our small piece and we double it, because we have two of them, to equal our large piece. So it's not exactly the same as this problem, but really similar. So you could also take half of this and set it equal to that. So you could say 2y plus 6 equals 1/2 times 7y minus 12. You deal with fractions in that case, so I didn't want to do that, so I decided to do the double route. So we distribute this 2. We get 4y plus 6 equals 7y minus 12. Subtract 4y from both sides, so minus 4y minus 4y. We get 6 is equal to 3y minus 12. We add 12 to both sides, and we get 18 is equal to 3y, which we then need to solve. I almost circled that. We need to solve by dividing by 3, and we get 6 is equal to y. I don't want 3y, I just want regular y, so make sure I continue all the way through. So in that case, what we have there was, let me check my work here actually. My math seems a little bit off here. Hold on. Let's see here. Oh, that's why. Okay. Little mistake here. So when I distribute this, this should be a 12, not a 6, which is going to change some things here. So let me go back here. So 2 times 6 is 12. So that'd be a 12 here. And 12 plus 12 is 24. And 24 divided by 3 is 8, which makes a little bit more sense. Okay, so I just make sure I need to multiply myself there. So again, if you have a small piece, you double the small piece to equal the big piece. If you have 2 small pieces, you just set them equal to each other. Again, it's in the name, mid-segment. So think mid, bisect, cut in half, equal, that sort of thing. Okay, now we have this rectangle line. So things you need to know about a rectangle. All the angles are 90 degrees. The diagonals are equal to each other. And as with all parallelograms, the diagonals cut each other in half. So once again, we have bottom half, top half. So this is another case of having the first part of the diagonal equals the second part of the diagonal. Because, like I said, they're both, whoops, forgot the 1. Don't want to do that again. They're both going to be equal sections of each other. In any parallelogram, rectangle, rhombus, square, parallelogram itself, the diagonals will always cut each other in half. So we subtract 5x from both sides, we get negative 8 equals 2x minus 14. Then we add 14 to both sides. We get 6, so 14. We get 6 is equal to 2x. And we divide by 2, and we get 3 is equal to x. So once again, if they ask you for the entire length, you would have to plug 3 back in and figure out each piece and then add together. But if they just want x, that's all you have to do is, again, take the bottom piece, take the top piece, set them equal to each other, and solve. So diagonals always cut each other in half. So make sure you can set each individual piece equal to each other. We have Genji here, who's a kite. And so in this case here, for a kite, you should know that consecutive sides are congruent. Now, usually you shouldn't go by the picture, but if they mark the sides here, it'd kind of be superfluous. So it can be kind of inferred here that GE and EN are congruent because they look to be about the same length. And GJ and JN are congruent because, again, it's a kite. So side by side, sides have to be congruent. So if these two sides aren't congruent, that means these two sides have to be. And usually a kite has either the top 2 and the bottom 2 congruent, or if this was turned on its side, it'd be the left 2 and the right 2 congruent. But in this case, again, it's kind of pretty clear to see that because they told us it's a kite, the top 2 are going to match up and the bottom 2 are going to match up. So once again, we end up with the case where we just set up 6z plus 8 is equal to 3z plus 15. And then again, we solve through. So we minus 3z's at both sides. We get 3z plus 8 is equal to 15. Minus 8 minus 8, we get 3z is equal to 7. Divide by 3, and we get z is equal to 7/3, or 2.3 repeating, however you want to call it. So as you can see here, if you have 2 side pieces, they're probably going to be set equal to each other. There's really not much difference about side lengths there. Angle lengths are either going to be 180 if they're side by side, or if you have like 2 angles in the corner of a rectangle, they might add to 90. So for example, something like this, if I give you a rectangle here, and let's say this was the diagonal, that's a really poor diagonal. Let me try that again. That's a little bit better. And let's say I gave you this angle here and this angle here. These two would add to 90 because if you know it's a rectangle, you know that these sides are going to be congruent. Other than that, they are also usually going to be equal to each other. So when in doubt, set your two equations equal to each other, and you can maybe at least get partial credit, because most of the time that's going to be the case, especially with sides. Some of the other stuff that doesn't necessarily specifically do with parallelograms is just general polygon stuff. So this one's an interior angle problem where you have all the inside angles of a polygon, and you want to find out how big the other angles are or what the variables represent in this figure here. So in this case, if you have the inside angles, you have to go back to that formula of n minus 2 times 180. Remember, this gives you your target number or your target value. So n minus 2 times 180 means you have 1, 2, 3, 4, 5, 6, 7. So you have 7 sides. So you do 7 minus 2 times 180, which would be 5 times 180, which would give you 900. So 900 is my target number. So everything here added together should get me 900. So that means we can make an equation. So we're first going to add our x's. So 4x and 2x are going to add up to get 6x. Then we're going to add up all the non-x's. So 133, 105, 140, 100, 125, and even 5. All those non-x's, we're going to add all those up. If you do it with the calculator, you get plus 608 equals 900. And then you solve it through. Subtract 608, subtract 608. We get 6x equals 292. Divide by 6, divide by 6, and we get x equals 48.6 repeating. So again, you're still setting up an equation like always. It's just that you have to do this little n minus 2 trick to get there first, because you have to know what the equation has to equal to in order to be an equation. So that's kind of why we went down that route. So don't forget about this n minus 2 times 180 business, and that is if you're dealing with inside angles only. This only works for interior angles. If you have exterior angles, like say this one right here, if you have outside angles, there's no formula to remember. All you have to do is that this is going to equal 360. So the outside angles kind of circle around the shape, and because they circle around the shape, they're going to add to 360 just like a circle does. So outside angles add to 360, inside angles have this formula you need to know to figure it out. But again, same idea afterwards. You add up all your x's, in which case all we do is have 6x. You add up all your non-x's, so 5, 43, 68, 35, 70, and 86. We're going to add those up. We get 307. And then we start our run through here. So we subtract 307, subtract 307. We get 6x equals 53. Then divide by 6, divide by 6. We get x equals 8.8. Oh, that's a weird 8. Let me try that again. 8.83. Repeating, I believe. So again, outside angles will always add to 360 when you set up the equation. Inside angles will always add to this formula here, whatever that gets you, when you set up your equation. And then after that, it's just a matter of combining like terms to get the other side. And once again, make sure you read the directions, because they ask you to find the missing angle. You have to plug that x back into the appropriate angle and make sure you get the degree of that angle rather than just x. So here we have a rhombus, a little bit change of pace. Find the value of x is if RAO, so RAO, so that's that angle right there. If RAO is 6x minus 12. Well, if RAO is, if RAO is 6x minus 12, that's part of the diagonals. One thing you need to know for a rhombus is that in a rhombus, the diagonals are going to be perpendicular to each other, which means all the diagonals are going to make nice right angles. And you should know that a right angle is worth 90 degrees. So when I set this up, it'd be 6x minus 12, which is the angle, is going to equal 90 degrees. Because again, it's at this intersection of the diagonals. So this is going to be a 90-degree angle because it's a rhombus. This is only true for rhombi and squares. Rectangles don't have this, parallelograms don't have this, rhombi and squares do. So we'd set up this equation, and again, we'd solve. So plus 12, plus 12, we get 6x equals 102, and they divide 6, and we get x is equal to 17. So once again, figure out what it's going to equal to, in this case 90, set up your equation, and solve it through. Just again, you have to just remember the properties of the different shapes. Rhombi diagonals always add up to 90. This was the trickier problem in terms of wording. So it says in a regular polygon, each interior angle measures 162. How many sides does the polygon have? Okay, so this takes a little bit of thinking. On a regular polygon, each angle is 162. We don't know how many sides it has. So we'll say it has n sides. So we have n sides. Well, if it has n sides, that also means it has n angles. So if it's like in a triangle, it has 3 sides and 3 angles. In a quadrilateral, it has 4 sides and 4 angles. So if it has n sides, that means it also has n angles. And each angle is 162. So I have 162 n's, right? N angles, each is worth 162. So altogether, it's 162 times n. If there were 20 angles, it'd be 162 times 20. If it was 25 angles, it'd be 162 times 25. But each angle, I don't know how many, but each one is 162. So this is the interior angle sum, essentially. This is all the inside angles together. Every 162 interior angle put together is 162n. That's going to be equal to the formula we originally started with, n minus 2 times 180, because this is also the interior angle sum, just another way of saying it. This represents what all the angles should add up to be. And this also represents what all the angles should add up to be. So these two formulas should agree. So I'm trying to figure out what n would make these two formulas agree. What n would make it so that 162 times it is the same as doing this formula over here. So you would set these equal to each other. The degree times n is equal to n minus 2 times 180. And you solve it through. So there, you get 180n minus 360 is equal to 162n minus 180n minus 180n. You get negative 18n is equal to negative 360. Divide by negative 18. Divide by negative 18. And we get n is equal to 20. So there are 20 sides in this polygon because 20 is the only number that would make both these equations agree. 21 wouldn't do it, 22 wouldn't do it, 23 wouldn't do it. 20 is the only number of sides this polygon can have because it's the only number of sides that would make both these equations agree on how big the interior angle sum is. If you want to try to figure out, type in 20 minus 2 times 180. So if you do that, 20 minus 2 times 180. If we pull that up, that'd be 18. Whoops, turn on here. Clear that. 18 times 180. We get 3,240. And if I just do 162 times n, so 162 times 20, I also get 3240. So this is the only number that would make those agree. So that's the only number of sides this polygon can have is 20 sides, or 20 angles too. So 9 and 10 are just about basic area and perimeter review. So let's do those real quick. So we'll do P for perimeter, A for area. So perimeter is adding up all the outside edges of the shape. So in this case, it'd be 15 plus 7 plus 12. Why not 5? Well, because 5 is a dotted line, which means it's representing the height. So it's not actually part of the side of the shape. It's just kind of an outside measurement that they're doing just for simplicity's sake. There's no real way to do it on the inside, so they just have to kind of put the height on the outside. So it's not considered part of the shape. It's just the dimension of the shape. So you add these together, and you end up getting 34. And that's what the perimeter is, 34 centimeters. For area for a triangle is 1/2 base times height. So it's going to be 1/2. My base number here ends up being 12, and my height number ends up being 5. How do I know that? Well, because of this right angle. This right angle touches 5, and it touches this bottom part here, which is representing of 12. So it'd be 5 times 12 as my base and my height. So use the right angle to kind of guide you as what lines you should be working with. And again, we don't need to figure out how big this dotted line is here. That's just for reference. This dotted line does not actually exist. It's just there to help you get some perspective about where the height is going from. So if we do this real quick, 1/2 of 12 is 6. 6 times 5 is 30. So it'd be 30 centimeters squared. That's a 3 there, 30. So again, this just formulas you have to remember. Add up all the sides for perimeter, and then 1/2 base times height for area of a triangle. For rectangle, it's pretty similar. So perimeter is, again, add up all the sides. So 3 plus 23 plus another 3 down here plus another 23 over there. So don't forget to write in the sides that they don't write in for you. So 3 plus 23 plus 3 plus 23, add them all up, you get 52. And for area, it's just length times width. So 3 times 23, which gives you 69. Now this would be miles squared, and this would just be miles. So again, this is just, I forgot to write in, this is just 3 plus 3 plus 23 plus 23. 23. There we go. So add up all the sides for perimeter. Remember the formulas for area. Base times height for rectangle, 1/2 base times height for a triangle. Or some people say rectangle, whoops. Some people say rectangle is length times width. Same deal. And then lastly, we have the proof. So once again, for a proof of triangles, you're trying to match up as many congruencies as you can get. So you can get a side angle side, or side side side, or angle side angle, or angle angle side, or HL. Those are your goals. Okay? You're trying to end at one of these 4 spots when you're trying to prove triangles congruent. Let's quickly mark what triangles we're looking at first. So OWV, so that's this top one, and RWE, that's this bottom one. So these are the 2 triangles I'm going to focus on. So let's go ahead and make our 2 columns here. So we have 1 column, 2 columns. Our given goes first, and then we'll give ourselves just a few lines here. It's not a very long proof, but we'll just put in some lines just to be sure. There we go. And then, of course, we are going to start, as always, let me shrink this out a bit. We're going to start with our given. Okay, given. Whoops, given. There we go. So it's a rectangle. So I need to think about, okay, what do I know about rectangles? Well, I know that each of these angles is 90 on the corners, but that's not really going to help me because my triangles don't use the corner angles. They use kind of portions of them, but like this triangle up here, OWV, that triangle there doesn't really use that entire right angle. It just uses a piece of it. So the fact that I have right angles is probably not going to be too helpful here. But what I do know about a rectangle is that the diagonals cut each other in half, right? So in a rectangle, this half of the diagonal should be equal to this half of the diagonal, and vice versa. This half of the diagonal should be equal to that half of the diagonal. Well, that gives me 2 sides right away, so that's probably something I really want to go with. So I probably want to say that RW, the lower half, is congruent to WV, the upper half. And I also want to say, for the same reason, that OW, the upper half, is congruent to WE, the lower half. And why are these congruent? Well, again, it's a little bit of lengthy wording, but you'd say you'd say not opposite, you'd say diagonals of a rectangle bisect each other. If you just say definition of bisector, that works as well, because that's technically what it is. You're bisecting the sides, so therefore, by definition, you have both halves congruent. So that'd be an okay reasoning as well. Then you have a few options here. You could go with like side angle side and say that, okay, you have vertical angles here, so this angle would be congruent to that angle because they're vertical. And that could be one way you go about it. Maybe even an easier way would be to say that you have OV and RE congruent because they're opposite sides in a rectangle, and that'll get you side, side, side. So you could say OV, that side, is congruent to RE, the bottom side. Why? Well, because of, let me type this out here. Why is the top and bottom congruent? Well, because opposite sides, sides of a rectangle are congruent. Try that again. Rectangle are congruent. And then the final thing we can do is say our proof statement. So we can say that triangle OWV is congruent to triangle RWE by side, side, side. And once again, you could do side angle side by getting these two vertical and saying it's a side angle side congruent. You could use alternate interior angles to get these corners congruent, like this one right here, congruent to this one down here by alternate interior angles, and then maybe try going for a side angle side that way, or maybe even an angle side measurement. So you can probably do almost all these here. With the exception of HL, you could probably finish this proof in almost all of these ways, depending on how long you want to take it. For me, side is always easier, just because I like using opposite stuff and just saying that they're congruent, because that's pretty easy for me. But if you're the type of person that likes dealing with angles and verticals and alternate interiors and all that, that might be easier for you. So once again, when you have these proofs and you have some options, pick the one that works best for you. That wraps up this video here. Again, make sure you remember your basic properties about quadrilaterals for parallelograms, squares, rectangles, rhombi, trapezoids, and kites, because again, you're going to need them for your proofs and for setting up your algebra. If you don't know that, the diagonals cut each other in half, and opposite sides are congruent, and opposite angles are congruent, and consecutive angles add to 180. If you don't know those little details, setting up the algebra is going to be a lot more difficult than it should be. Hope you enjoyed the video. Have a good day.